for the system given below, that looks like this, the mass. And we're going to define X is up. I'm going to define a spring. A base, a Y, a K, and a C. And excited at the base, should the system be excited above or below the natural frequency if the transmitted force in the design is the design limitation? So we want to consider that zeta is equal to 0.1 and the overdamped case, the underdamped case, and zeta is equal to 2 for the overdamped case, right? So if we plot this out, and again, do we want it to oscillate above or below the natural frequency? This is my transmissibility of both the force and displacement, right, onto one plot. So this is for zeta is equal to 0.1. And I have my transmissibility for force and displacement. So if we want to minimize the force, right? So this force is my blue line. If we want to minimize the force, do we want, in an underdamped situation, do we want to drive the system above or below its natural frequency? Say that out loud. Below, right? So we want it below because I am much lower here than I am here, right? What about for an overdamped case? Anyone want to take a guess at that? So for an overdamped case, again, we have this. If my force transmissibility is my issue for an overdamped case, do I want to go above or below? Below. Kind of what about displacement, right? So what if displacement is my limiting factor? For an overdamped case, it doesn't really matter too much unless you have a very tight clearance, right? But for an underdamped case, right, you actually at very high frequencies, you get very little displacement, right? So kind of something to think about when, I think there's a homework question to like mass, machine mass. It might be a practice problem, but like designing dampers to limit force transmissibility into machines. Like milling machines, you're very worried about kind of like displacement transmissibility because you're worried about tool chatter. And then on, you know, connections or mechanical components that absorb shock, you're on average very worried about force transmissibility.